welcome to When Sharing Isn't Caring. So my name is Russell Wolf. I've been using Kotlin Multiplatform from pretty much day one, and we'll talk a little bit about some of the things I've learned over that time. So just kind of little poll to start off. Who in here has used KMP at all? Good amount of the room, that's nice. Who's using it in production? Nice, nice, nice. Who is hiring for it? Anybody? Anybody? Guess not right now. That's fine. I'm employed right now, but just in case anybody else was looking. For the people who aren't familiar, a quick overview. So Kotlin Multiplatform is Kotlin's ability to run code not just on the JVM, but also on several other platforms. So in addition to the JVM, there is native code, which includes things like iOS or native desktop targets. There's JavaScript for web things, and there's WASM for newer and shinier web things. And the general philosophy is to share the code that you want to share, but run everything within a native environment, and interop also with whatever platform that you're running on. So just like JVM Kotlin focus very strongly on being able to interop with Java, on other platforms you can interop with the native APIs of that platform. And the general kind of mindset and organization of it is that your shared code is just one more library. And that library might be big or small depending on what your use case is and what your app is. Maybe it's just like some small chunk of business logic that you don't want to write twice, or maybe it's just about everything. Maybe you're using Compose Multiplatform and you're trying to share 100% of your code. But in whatever scenario you're in, you have access to common Kotlin APIs, and you have the ability to talk to whatever platform you're on. And as people start trying out Kotlin Multiplatform, often a question of this form starts to come up. Like, how do I do this thing that I know how to do on Android? How does it work in the Kotlin Multiplatform world? And I've seen versions of this question come up all the time on Slack or on social media or on Stack Overflow. And one of the messages I want to give you in this talk is that this is not always the right question to ask. So of course, maybe there's already a library out there that does whatever you're looking for. I mean, maybe your use case is even covered by the standard library, which has some nice utilities and things in it. Jeff Rains now maintains a website called klibs.io, which lists multi-platform libraries that are published on Maven Central. And so that can be a place to look if you're trying to support some use case and like the standard library doesn't have what you need, or you're not sure how to build what you need yourself. And like this is a nice big collection of libraries, but it's not infinite. It's still a somewhat young ecosystem. Yeah, you should appreciate it though if there is a library for a use case, because when I got started in this stuff, there was nothing. And even today, like, you will sometimes have a use case where there's not going to be a library that fits your needs, or maybe it's written in a different style or something, or it's like you're in an organization where you can't trust a library from a single maintainer or something like that. But luckily, underneath Kotlin Multiplatform is always going to be your native platform. So anytime you're wondering, how can I do something in KMP, and you're not sure how, what you can instead ask yourself is, how do I do that same thing natively? Like Android and iOS are both very mature platforms that have been around for a while. People have solved a lot of problems on them. And so if there's not a kind of multi-platform ready way to do what you need to do, there probably still is a native one. And it won't always be easy or trivial necessarily to integrate these different native solutions. There's always going to be a little bit of a boundary layer where you have to fit your Android Legos to your iOS connects or something like that. You'll often find yourself writing some sort of adapter layer. But that's still going to be less complicated than writing everything twice in most cases. And regardless of what kind of extra little bits of architecture you have to do, there's no like absolute technical barrier to using native solutions from KMP. So we're talking about platform code today. What is platform code? So here's a kind of schematic of an Android, or of a KMP library module. Each of these boxes represents a source set. So kind of by default, you have in a mobile app, you're going to have a common sources, you're going to have iOS sources, you're going to have Android sources. And like in the technical details, this is a little bit more complicated because Android might have different build flavors, you have debug and release, iOS has different targets for the device and the simulator and things like that. There's main and test sources, but this kind of summary captures most of the important details that you'll need to think about as a mental model. And when you build for Android, you take the Android and the common sources, you bundle that into a AAR Android library, or maybe you're just using, like maybe you're just targeting JVM without Android-specific stuff, and you'll make a jar file. And when you're building for iOS, you'll create a XE framework out of the common sources and the iOS sources. In a lot of cases, the common code, the orange box, is going to be the bulk of the library module. And the platform code is kind of little bits that support it. So the common code might have an interface or an expect declaration or something like that, and the platform codes will be the implementations of that. And there might be some other kind of platform-specific, either utilities or entry points or things like that, that help support how to kind of run that code. But in the end, typically this is just a library module, and you'll also have some app module on top of it. So you're on the Android side, like this will look like, this will just be kind of like a separate Gradle module that's running your typical Android plugins and not the multi-platform one. On the iOS side, this is going to be an Xcode project. It's going to be like it's going to be written in Swift or Objective-C rather than Kotlin, which is a nice way to highlight, like, sometimes your platform code, even in a more general case, is in another language. And everything at this app layer is going to be platform specific. And these app layers are going to, like as modules, they're also what's kind of in charge of configuring your final binary, like making it into an actual app that you can upload to the stores and things like that. You do sometimes see a setup like this where those two engine modules are kind of collapsed into one. I'm personally not usually a huge fan of this, but it's becoming more common in a lot of composed multi-platform samples. So know that that's an option. Some of the stuff with the Gradle plugins is evolving a little bit as like JetBrains passes off the maintenance of the Android things to Google, and so some of the configuration of that is all going to change, but we're not going to go too much into those details right now. But I usually like to keep these separate just because it helps you parallel, like it helps your Android and iOS side parallel each other, and so when you're organizing things and thinking about where things live, you can kind of keep the same separation on both platforms. And of course, just your shared code in your app modules is probably not your whole app. Your app layer might have other modules it depends on. These might be yours, these might be third-party things, these might be like other external libraries. And this is one of the things that I really, really love about Kotlin Multiplatform is your shared code is just one more library, and that's not kind of forcing a lot of things on the rest of your app and your configuration and things like that. You still have access to all of your same native tools and APIs. And in addition to depending on other native libraries from your app code, you might also have some multi-platform dependencies from your shared code. And these, in practice, will generally kind of look pretty similar, like schematically will look similar to what your shared code looks like. There's going to be some common code, some platform-specific bits. And in addition, the platform-specific parts of your library module might also depend on other native libraries. So maybe to implement some common API, you want to call out to some other native Android dependency that's going to kind of do the heavy lifting for you. So you depend on that from the Android sources of your shared module. So this now is kind of like a roughly complete schematic of like what your whole app architecture might look like in terms of dependencies. Like any of these things will probably be duplicated. You might be dependent. You might, excuse me. You might have several shared libraries of your own. You might depend on several other libraries and dependencies. But anywhere on here that isn't in orange is platform code. And the things that aren't faded out here are like the things that somebody else might have written, the things that you are able to leverage from the wider existing community, existing ecosystem of Kotlin Multiplatform, and not including the like any KMP libraries you might depend on. Like these are the things that you might have still been using if you weren't using KMP. And so there's lots of different options for kind of how and where you can leverage platform-specific solutions to do the things that you need to do from common code. One way to kind of think about this platform code is it's often kind of the code that you would have written if you weren't sharing everything, if you weren't sharing anything, excuse me. And that gives you kind of a floor that you can build on top of to do more shared code. So often you'll do something like, or you could do something like starting from like two separate apps that have different interpretations of some similar feature, and you extract some shared API service out of that. And initially you're delegating a lot of that to platform things, but as you build out more common APIs, you can build up your shared code more and more, and you have more APIs that then your new shared code can call out to. Like as you build common APIs around things, it lets you do more things from your shared code. So what do development workflows look like in this kind of environment? Different teams will often work in different ways. Different projects have different sorts of structure. And what you look for from your platform code and kind of the ways that you might write it are going to differ depending on your setup. So one common starting point is you are some big existing application. You have two separate Android and iOS native mobile teams. You're trying to migrate towards having some shared code, but you've never done it before. And you're often kind of somewhat siloed teams that are learning to work together. Like different organizations kind of have different levels of coordination and collaboration between their native teams. But once you're trying to share code and really actually develop features and things together, usually you're doing something new that you haven't organizationally done before. You'll usually start with a small kind of core of some shared code and start to incrementally grow it over time. And your existing code becomes your initial platform implementations of whatever common APIs you want to create. You'll then need to wire that shared logic into existing bits of code. And like the interop between your shared code and your existing platform code becomes important. And one thing that often comes up in these sorts of teams is there's always going to be some people on the iOS team that aren't that interested in writing Kotlin. And one important point I want to make about this is this person is not wrong. Like someone who has spent their career learning Swift, learning iOS well, they're not wrong to want to continue to leverage that knowledge and experience. And it may be beneficial to the company to continue to do that. So leaving parts of the code base in Swift lets the iOS team continue to use their skill set, their institutional knowledge, and depending on your teams and your app and things, like different teams will draw the line in different places for what they want to share and what they don't want to share. For example, like a lot of people talk about trying to share code all the way through their view models and then just have separate UIs. And I've actually worked with a team that started moving in that direction and then backed off of it. They found that they could build iOS screens much faster if their iOS teams were building their view models in Swift and just sharing the data layer underneath it. So you, as you do more, will kind of find what works for you and your team. But you do need, like, if everybody on the iOS team is kind of taking this sort of attitude, then it's going to be much harder to get buy-in and to kind of make this multi-platform experiment work. You do need some people from the iOS side who are willing to come in and write some Android code, or write some Kotlin code. And hopefully what that means is over time you can start to kind of drill some holes in the wall and share more and more of your code and architecture. It's not necessarily going to be fast or easy, especially for a large legacy code base. But over time, you create more flexibility in your code for what you can share and in your organization among your teammates in how you work together. And ideally, you move towards not just being separate Android and iOS teams, but a mobile team that has some people with more Android and iOS experience or expertise, but are willing to work together and coordinate and kind of build things that work for both of them. Variation on this pattern is sometimes you have a lot of Android code and little or no iOS code. You're trying to just kind of port that existing Android Kotlin into shared Kotlin that your iOS app can use. So I've worked with a team once that was they had they were working in a environment where they were kind of provisioning pre-configured Android devices to their workers, and then they wanted to convert to a model where those workers could bring their own device instead. And so suddenly they had this big existing Android code base that they also needed to be able to run on iOS for people, like for workers who had iPhones. It takes some work to kind of go through and figure out, like, what are the pieces of your existing app that are shareable, what can be moved into shared, and what are things that you need to re-implement on the iOS side, either in Swift or in Kotlin. And this is a place where, like, you may have, like, you're probably starting with a team that's mostly Android experts, and you're going to, like, you can get in trouble if you don't bring in some iOS folks to help. And if you don't already have an iOS team, you may need to do some learning or do some hiring to help make this project work. Other teams, especially kind of newer apps, are more kind of ground up shared. So you're building a fresh greenfield code base. You're doing as much shared Kotlin as you can. You want to still leave the UI native. Maybe you really like that new liquid glass effect and you want to kind of keep that going in Swift. You might have some other code that you want to keep in Swift too for whatever reason. Maybe there's some iOS specific feature that you want to hold on to. Usually it's fairly, like, it's usually you have a lot of flexibility to, like, you're usually building new things and you have more flexibility to you have flexibility within your architecture to make sure that you can kind of pass in whatever platform dependencies you need. Again, you need to have some people with iOS expertise to build that Swift UI layer and to kind of build whatever other iOS specific pieces that you need. And the other kind of big category of teams that you might see is people who are kind of trying to share everything. They're doing shared UI with Compose. And at the start, it feels like, oh, we don't need any platform code because we're doing everything shared. And then this question comes back up. How do I do some new thing in Kotlin Multiplatform, and I can't find the API, and there's not a library for it? Any mature enough project will eventually have a need that can't be solved with an existing library or some feature that depends enough on platform-specific things that it makes sense to do a platform-specific implementation. And so even in what started out as a 100% shared Kotlin code base, you'll eventually probably need to add some platform code to it. And this is a team that has big problems if they're not prepared for this issue, because they often won't have much iOS knowledge. And so it pays to be ready for this again by either trying to build out that expertise as you go or by hiring some iOS experts as you're scaling up more. And yes, there's lots of other, excuse me. There's, let me put this somewhere where it's a little more flat. There's lots of other team setups and workflows, so this is just kind of a taste of them. For example, I just started working for a company that's using shared Rust code for an SDK that we're then building a Kotlin Multiplatform API around and some other like APIs and some other languages around. But whatever workflow you're in, you're going to need some platform code. You're going to need some devs that are experienced in the details of your platforms in order to be able to write that code. So let's look at some code examples. So like what are code patterns that can help you when you're trying to architect this code? And these are all going to be real world examples that have been maybe simplified a little bit, coming either from some of my own open source work or from clients who I've worked with names changed to protect the innocent. And we'll start with multi-platform settings. So this is a library I maintain that has it's essentially a key value store wrapping around shared preferences on Android, user defaults on iOS, and a number of other implementations as well. It has a kind of core interface called settings, and it has platform-specific implementations of that interface that delegate to the platform-specific storage. So in your Android code, you can have a shared preferences settings that delegates to shared preferences. In your iOS code, you have the same thing. You have a user default settings that delegates to user defaults. And this is nice and flexible in that you give your users the ability to switch out different implementations if they want to. There's also like a test, like a map-based settings that you can use in your unit tests. There might be other implementations, like multiple implementations on some platforms. But some users don't want to deal with that flexibility. Like they don't need the customization, and they just want to be able to do everything from common code. And so there's also this no-arg module that just has a factory function for settings that just builds a default implementation for each platform. And there's a nice just kind of like common pattern here that I've used in a lot of application code as well, where you have an interface in common with different platform implementations, and then an expect function to give it a default. And it gives you that balance of like, if you need the configurable, you have it, but if you don't, you can just call some common API. The other thing that this example highlights is that your like platform code enables you to do more things from your common code. So that no-arg module has this has no common logic. It just has this one expect function. But once it's there, now your common code has access to this new functionality. Now I can build now I can construct this object from common instead of from platform code. The more APIs you have like that, the more things you can do from common code. Another thing inside of multi-platform settings is there's some logic on the iOS side that cares about integer sizes. So most platforms, even most Apple platforms, are 64-bit, but there's a couple 32-bit targets that are still floating around there. And there's this set integer function that changes between a Kotlin int or a Kotlin long, depending on the bit size of the platform that you're on. And so here, the expect actual is able to kind of hide those platform differences like deep within the library logic in a way that doesn't float to the API, because at the API service, you don't really care about that difference. So to kind of contrast the previous example, like sometimes you want to be able to float the platform differences. Sometimes you want to just kind of clean that up for your users so they don't need to deal with it. And both of those are possible to do. Another pattern that I've run into and used in a number of different apps is having something like, maybe there's a analytics manager that has kind of the business logic level of your analytics events. It has maybe different functions to log different events, or maybe there's different ways to structure this. Like maybe there's like an EM or something that's in your shared code that you use for each event. And there's this analytics writer interface that will then be implemented in platform code, delegating to the platform-specific libraries that your analytics provider has. So like most analytics services these days aren't yet putting out a KMP SDK, but you can still talk to their native SDKs from your native code. So you might have like an Android one written in Kotlin and an iOS one written in Swift that are talking to whatever you would have written, like whatever APIs you would have talked to if you were just doing it from a native app. And there's a common pattern here of having like some common logic container like that analytics manager with a platform-specific driver that just is in charge of the little bits of platform-specific code that are needed to make that common logic work. And so those platform-specific drivers can then use your platform dependencies, and then you can, like it fits well into a lot of common like clean code and architecture practices that you might have, where you can, like you have this high-level logic class, and you're injecting some dependencies into it that are platform-specific that are just doing a little bit of the work. And you see this, pattern in a bunch of public libraries. So for example, KTOR has a HTTP client with a lot of common logic in it. And like within that, there is a HTTP client engine that has a number of different implementations depending on what you want to be kind of the low-level driver of your client. And most of those are platform-specific. One project I had a couple of years ago, this was one of those examples of a bunch of existing Android code that we wanted to move over into iOS land. We had this big sync service class that was in charge of kind of the business logic of this data synchronization operation. And it talked to this socket connection class that was more lower level, was talking to a lot of like Java socket APIs. These two classes weren't super well abstracted, and we wanted to find a way to share the sync service logic and like as much of the socket connection logic as we could, without, but we needed to be able to kind of break that Java dependency. And there was like even on top of this, there was a bunch of complicated data sync operation logic that was making use of all these classes, and we wanted to be able to move as much of that as we could into shared code. And so what we ended up being able to do was move that socket connection class into common, and then move everything on top of it that depended on it into common by kind of carving out this interface for what the direct socket operations were. So we had a socket interface and a factory interface to construct sockets that on the Android side just talked to the existing code. Like we just kind of moved that code over into this other class. And then on the iOS side, we had to write some new logic, but it was just for this little narrow platform-specific bit of how do we do these networking calls. And then the platforms just needed to pass their implementation of that or that factory interface, excuse me, and everything else on top of it could run from common code. So yeah, the kind of general lesson there is like you can often find these kind of seams where there's some parts of your code that are easier to kind of move into just shared logic, some that need to do something platform specific, and you can kind of wrap an interface around them maybe that lets you create that separation and then move, like do the platform code, do only the minimal platform code on your platforms. And one note I like to highlight about that is like a lot of what you're doing here is the same sort of thing you might be doing if you're refactoring legacy code. Like if you have some old monolith class that you've been maintaining for 15 years, and you want to kind of peel some logic out of it, like you're often doing a similar thing where it's, can I wrap an interface around something like this, maybe write some tests around it, and then pull it out and separate it so I can use it somewhere else. One last example I'll show is this was an app that needed, it was displaying local notifications to the user based on some schedule. So there was this repository class in common that had a function where you could ask it for a flow of what are all of the notifications, what are all the reminders that I'm expecting, what are all the reminders that I want to get notifications of is essentially what it was. And then it would do all of that scheduling in a platform-specific way. So on Android, we, like at initialization time, we would subscribe to that flow. We would call out to Work Manager to kind of asynchronously schedule those notifications to happen, even if we were in the background. On iOS, we had to add some extra plumbing around, like this was before tools like Sky existed, and so we wrapped that flow at the Kotlin layer and just kind of had a callback for when we get a new event. And then from our Swift code, we could subscribe to that, pass a callback that would then invoke the iOS local notification APIs and then signal when that was complete. And the kind of general, like one of the big pieces of this is like we're doing all of our initialization in kind of a very platform-specific way where we're asking the shared code for the data that we want, but then it's the platforms that are responsible for feeding that into the platform-specific notification APIs. So like even though the different platform APIs like may look very different and may behave in different ways, you're still able to take this shared data source and feed it into your platform APIs. Which I just said that same thing already, yeah. And one of the other kind of general nice things about this is like when you're dealing with platform things, for the most part, the KMP side can get out of the way. So you might need to do a little bit of plumbing to convert your Kotlin flow to something that iOS can consume, or things like that. But once you're kind of pulling your data from your shared code, you have access to all of your usual platform-specific things. You can do whatever notification customization you want to do and things like that. So that was a bunch of code. Hopefully it wasn't too overwhelming. What are some of the general lessons that we get out of all of this? One of the big ones is you might be writing shared code, but you are running on some platform, and don't be afraid to use that. Like in a lot of cases, you'll still have kind of most of your things in common and a little bit of platform-specific stuff supporting it, but you're not fully taking advantage of Kotlin Multiplatform if you're not using some platform code when you need to. Like that's one of the big things that KMP gives you over other class platform solutions, where it's a lot harder to do that interop, and you should take advantage of it. Another big lesson is iOS code, even in a shared Kotlin world, iOS code needs iOS developers. Like your mobile app is one big team. And the iOS side has experience and expertise on their platform. So don't just throw things over the wall at them. Work together with them so that together you can build something that works well and does what you need. Good API design is universal. So like a lot of the sorts of architecture and design patterns that you may think about in settings where you're just trying to kind of like do clean code, do clean architecture, and things like that. Those sorts of practices will naturally lead to code where it is easier to slot in the platform-specific bits where you need to. Again, like the sorts of things that you do to refactor legacy code are similar to the things that you might do to refactor code into something that you can share. Like the details of that might be different. Like the details between the legacy code and the shared code might be a little bit different. Like where you draw the seams might be a little different, but a lot of the ways that you might approach it will be similar. I don't know how well this will play to a German audience versus a US one, but the US had a president years ago who said, ask not what you can do for your country, ask not what your country can do for you, but what you can do for your country. And you can take that same attitude towards Kotlin Multiplatform. If the KMP ecosystem is not giving you what you need, you have the ability to create those APIs and provide it. And this is often the first step towards publishing a library. So for example, like when I wrote multi-platform settings, like part of the inspiration for that was writing a little demo app that talked to shared preferences and talked to user defaults, and realizing like, oh, it would be nice to have a common API for this instead of needing to write it twice. Remember that 100% of shared code isn't necessarily the goal. Like ultimately, we're software developers, and our goal is to write good software. And we'll do that more efficiently when we're sharing code, but sometimes the best software that we write won't have everything shared, and that's just fine. The next time this question comes up, hopefully you're a little more prepared to answer it. So thanks. And I think we have a couple minutes for questions if anybody has some.